Hi, I'm Bridget Jennings. I'm the Managing Director and Senior Occupational Hygienist at Chem Safety. Joining me on the panel today is Paul Robertson, who's a Director and Senior Consultant as well. Sam McGee, who was going to join us today, is also one of our Senior Hygienists, but he is currently out doing respirator fit testing for some essential service businesses. So he may jump in later, it just depends on when he gets the fit testing finished. I'm sure you'll all appreciate that that is a very important part of this lockdown response. So what I want to first discuss is just a little bit on how we're going to run the panel discussion today. So you'll see below on the bottom of your screen, if you wiggle your mouse around, there's the Q&A section. So if you can please upload your questions there now. We really want to have this discussion as more about answering your questions rather than us talking to you. So it's really important that it's interactive. So please put those questions in and we'll answer them as they crop up. I also just wanted to talk about a little bit about welding fume in general, and Paul's going to talk to us a little bit about the health effects of welding fume as well, and then we'll get started. As occupational hygienists, we've seen a lot of focus being put on welding fume and controlling exposure by WorkSafe. We've seen quite a lot of improvement notices come through for welding fume, and that's part of WorkSafe's strategy for controlling exposures to hazards like dust hazards, inhalation hazards. It was also part of the Breathe Freely website, which I'm not sure if you've all seen, but if you haven't, I really recommend that you go on that website. It's breathefreely.co.nz, and it's got some really good resources on controlling exposure to dust, and welding is one of the topics that's covered there. Some really good tools on not webinars, like toolbox talks and how to control things like silica and dust in construction and mining and crystalline silica and bench tops. Also, what WorkSafe has done when they reviewed the WES last year is that they've reduced the exposure standard for hexavalent chrome to 0.00002 milligrams per cubic meter, which is really low, and that's because it's very toxic, carcinogenic, sensitizing. But that means that us hygienists can't monitor down low enough, can't measure it in air low enough. So that does affect how we control exposure to hexavalent chromium, which is produced during welding of stainless steel. So that's just a little bit of a few of the challenges and why there's been such a focus on welding fume. So I'll head to Paul to just talk a little bit about health effects.
Hi everyone. Hope everyone's enjoying their day, has nice weather, and been out for a walk hopefully. I'm going to talk a little bit about the health effects of welding for a start. So they're quite different depending on what type of metals are being welded, whether it's stainless steel as Bridget mentioned, or if it's mild steel or aluminium. So they all have different health effects. And it also depends on which type of welding is used as well. They all produce different health effects as well. So it could be manual metal arc, could be MIG, or it could be TIG welding. As the metals are heated up during welding, they pass their boiling points and produce a vapor. The vapor rapidly collides with oxygen and other particles to form a very fine particulate, which we know as welding fume. And the composition of this welding fume will depend on the metal being welded. With mild steel welding, the fume will mainly consist of iron oxide, but there's also a small percentage of manganese and other metals which are used in welding rods and are present in low quantities in mild steel. Welding fume includes irritating gases such as oxides of nitrogen and ozone, which are formed during the welding processes. It typically causes respiratory irritation and metal fume fever. So metal fume fever can be described as similar to like cold or rhinitis type symptoms where you get upper respiratory tract effects. If you are exposed to welding fume over a longer term, it can lead to serious lung diseases, including chronic obstructive pulmonary disease, COPD. Used to be called chronic bronchitis and emphysema. It also can lead to occupational asthma and, of course, cancer. Welding fume is one of the top 10 occupational cancer causes in New Zealand, so it's a particularly important thing to control in your workplace. Stainless steel welding is particularly hazardous as the fume contains nickel and chromium-6 or hexavalent chrome oxides. These are highly toxic if inhaled. These metals are present in stainless steel and are released as fume at high temperatures. Both can cause cancer and occupational asthma. Repeated exposures to low concentrations of manganese have been shown to also affect the nervous system. Another health effect that most welders know about is the UV radiation that's produced from the welding arc. So this can affect the eye, get people with arc eye, and skin. So you can develop eye and skin cancers from the UV produced during welding. Another potential health effect is when you weld in a confined space. So if you're welding in a confined space, you have to think about toxic fumes that can build up and also low oxygen. So a confined space can be any space of an enclosed nature where there is a risk of death or serious injury. This could be from the rapid buildup of hazardous substances or from lack of oxygen. So you also don't just think about the spaces that are labeled confined space, because there are less obvious confined spaces like open top chambers, ductwork, and even poorly ventilated rooms can cause issues with lack of oxygen and buildup of toxic gases. In a confined space, you've got to think about shielding gases, so your argon, your helium and nitrogen, or even carbon dioxide. They can build up in the room if there's not good ventilation and cause asphyxiation. Welding could also act as a source of ignition for any flammable gases like vapors or residues that are being worked on. If there are any significant quantities of fine particulate dust in the air, plastics or any other materials that may burn, we have to consider that as a potential way that harm can be caused. And the other type of health effect that can be caused can come from coatings and residues that are on metal. So if you're not welding on bare metal or steel, then you've got to consider the fumes that might be created from metalworking fluids and oils and rust inhibitors. Zinc will vaporize to form zinc oxide fume. There could be cadmium plating on metals, which is can lead to a carcinogenic fume being produced. And also you could get organic vapors from paints or solvents used on the like degreasing agents, etc. There also might be lead oxide primers, which will cause lead fume, and even plastic coatings, which are going to release some nasties for you. So lots of things to consider when we're talking about the health effects and where they might come from with welding. But that's all. I'll leave it for now. Back to you, Bridget.
Oh, thanks, Paul. I've got a couple of questions that I'll answer together here. So one of them is, has the workplace exposure standard for stainless steel been checked, that it's not just a mistake? And the second one that I'll intertwine with it is, how does New Zealand's WES, so workplace exposure standard for hexavalent chromium, compare to standards in other countries? So I can assure you that WES isn't a mistake. It's actually very clear in the consultation document that they know that it's 10 times lower than the American standard, the ACGIH standard, which is 0.0002 milligrams per cubic meter, so 10 times lower. So it's not a mistake. I've had a couple of people ask me this, and yeah, no, it was made, the decision to lower it was made knowing that it wouldn't be able to be monitored. There were several groups that did respond to the consultation document outlining to WorkSafe that it couldn't be monitored at that level. which is why it just all falls back to control, which is really important. So the next question is, what is the priority on welding fume, protecting the breathable air or the protection of the person welding? So I'm going to make a wee assumption here. I'm going to assume that by breathable air, you mean the air in the workshop. So just the air that is sort of like the background environmental air, if you like. The workplace exposure standards are designed to protect workers, so workers carrying out the work. So when we do exposure monitoring, we're always measuring their exposure on the person. That's how we can use exposure standards to guide us on risk. So it's both, it's on people. So if there's someone welding, then we want to understand what their exposure is and making sure that that's being controlled, either through things like local exhaust ventilation or through PPE or general ventilation or something like that. But if we have someone who is not currently doing welding but is in the workshop, we still want to get to have an understanding that they're also protected from welding fume. Often in workshops we see when there's a lot of welding going on, there's that haze that builds up, and there's just sort of a smoky layer, and that can affect not just welders themselves but also the people working in the workshop doing fabrication type tasks. So it's both. But there will be different ways of controlling people's exposure depending on the work that they're doing. So we need, it's all about the person. We don't tend to do static sampling. So that's static sampling is where we just put an air sampling pump in the workshop and measure the environmental air, because we can't use the workplace exposure standards to compare the results to those types of measurements. We can use them to gain some information on what the background levels are like, but we can't use it to show that we're controlling exposure to those whizzes.
I see there's a question about how we compare with our workplace exposure standard to other countries. As far as I'm aware, we have the lowest workplace exposure standard. I think America, the NIOSH exposure standard is
hexavalent chromium.
Yeah, for hexavalent chromium. So I don't know if you touched on that, Bridget. But yeah,
just there's lots of other standards that we're using, obviously, for welding fume, not just hexavalent chromium. So they're sort of comparable. The other ones are comparable with other countries. The research, I think there was just more evidence that came out that hexavalent chromium is really carcinogenic and sensitizing, and there's links to disease, very strong links to disease, and that's why WorkSafe took that stance.
There are other industries where the hexavalent chromium limit or WES is affecting them as well, like the galvanizing industry, where they dip into what's that, chromic acid?
Sodium dichromate.
Yeah, sodium dichromate. Yeah, and yeah, they get high hexavalent chromium readings from that.
So we've got another question there. Is welding fume heavier or lighter than oxygen, or does it vary depending on any gases involved in the welding process or something else? So welding fume consists of different sizes of particulate. So we've got inhalable particulate, which is the sort of around the 10 micron size, and that's the size that can get sort of stuck in the nose. So and that can cause irritation and that kind of thing. So if you've ever done some wood sanding at home and then blown your nose and you've seen all that dust in there, that's sort of your inhalable particulate. And then there's also respirable particulate, which can get down deeper into the lung and cause disease. So with regards to being it heavier or lighter, we're always controlling its source. It's not, I don't think it's heavier than oxygen. I think
It tends to initially rise because it's so hot. It's coming from a very hot process, so it's going to rise on thermal currents. But as it cools down, as it gets up a bit, it will, because of the heavier parts of it, will settle down again.
Cool. So how small a number can we measure with current technology? And is this the limitation on what we can measure? And is the limitation on what we can measure New Zealand only, or is it a global limitation? So it's we can't source other analysis to measure lower either by looking overseas, like Australia or USA. As far as I'm aware, I have looked initially. There is some technology that I think can be used to measure down as low as we would need to, but it would require quite a large capital investment for laboratories to get down that low. And how small a number can we measure? We're looking down at around 0.002, I think, maybe a bit lower, but just not down at around the 4 zeros too. So yeah, we can get down pretty low. For most metals, we can get down with plenty detection limit left over, but just not for hexavalent chromium.
Yeah, the way to improve your detection limits is to either monitor at significantly higher flow rates, which will probably exceed the analytical method or the method that you're trying to follow. So not always practical, or monitor for increasingly long periods of time. So yeah, to try and capture enough sample that you can get a reasonable result out of it.
And we've got, are we behind in the way we monitor, test and manage? It seems newer here to other places. Regulatory body requirements that seem more mature. So certainly New Zealand is playing a little bit of catch up with the rest of the world in occupational hygiene. There is also just occupational hygiene and exposure to health hazards in general is behind globally. So we have a lot more deaths from disease than we do from safety incidents. So there's a lot that the world needs to do to protect people against these types of inhalation hazards, and that's why it's been such a focus for WorkSafe. We really made big strides in the last few years to monitor and manage those hazards. So the test methods that we use for exposure monitoring are global test methods. So the methodology is the same, but it's but for PCBs knowing that they have to do it and managing those health hazards, we've still got a bit of work to do. The introduction of the General Risk and Workplace Management Regulations and the new HAZMA Act has certainly raised awareness on the importance of exposure monitoring. And there are a lot more control options out there than there have been. So for welding fume, control options include local exhaust ventilation. So we've got systems that use a snorkel type capture hood that's movable. It's important that people are trained in how to use those properly. So it's drawing fume away from the operator and not up past the breathing zone. And there's been some really good improvements with respiratory protection, which is something that has to be in place for hexavalent chromium, with the sort of inception of PAPA, or positive air-powered respirators, which incorporate a welding visor with filtered protection. So I don't know if we've certainly come a long way. We've still got a little bit of a way to go, but monitoring, testing, same methods, we're using global methods, and we just need to do it.
Yeah, the other thing that's driving it is WorkSafe actively reviewing exposure standards that other countries haven't looked at for quite some time. So based on new evidence and new information that's coming through, they're looking to protect worker health as much as possible. And also other industry bodies like HASANS is driving health and safety and reducing worker exposure to front of everyone's mind and bringing up the quality in our industry.
So next question is, I hope this question isn't too general, but PCBUs seem resistant to doing proper exposure monitoring despite legislation on the basis that the impact is unlikely to affect their business because of the latency period of disease. How can we convince them to prioritise this? Good question, Tanya. Wish I knew the answer to that. I think there's more of a lean to looking after workforce. There is good evidence out there to suggest that good health and safety is that does generate more productivity. So there is that is part of why health and safety should be done, less sick days and all that. There's also the looming threat of litigation, and talking to some of the lawyers involved in workplace safety, or I hear them talking all the time about how there's going to be more and more litigation. So there's that stick to it as well, and not just waiting for, and businesses may not be prosecuted just because someone gets a disease, but if it's found that they're not controlling the hazard properly, there could still be prosecution because of that. But I hope that people just want to look after their team, want to do the right thing, follow the legislation. The legislation's there for a reason, and it's about worker health. It's to prevent people having disease in their later years, so that they can be around for their family. And you know, that's what we all want, surely. So I think yeah, the message is starting to get out there, but there's still a resistance in some sectors to it. So if you think of an idea,
Well, there is the legal responsibility to do exposure monitoring. WorkSafe will issue improvement notices if someone isn't assessing their hazards properly, or undertaking exposure monitoring. So they are required to do it by law under the Health and Safety at Work Act. So it's if you are having particular trouble, that is, you know, would you be comfortable if WorkSafe were to show up tomorrow with what you've done to protect your workers? It's a good way to ask.
And with being unable to measure hexavalent chromium, how do we know LEV is effective? Obviously, we must wear PPE, but I assume we should still be applying higher level engineering controls where practicable, given PPE is bottom of the hierarchy. Yeah, absolutely. What the difficulties with hexavalent chromium means is that we can't demonstrate that the LEV is effective, but we know that it's a higher level engineering control. So it means we can't just use LEV without PPE, but we should still be using LEV with PPE. So it shouldn't, just because we can't measure it, doesn't mean that LEV shouldn't be used. I think when we're talking about stainless steel, we should still be using those higher level controls, and LEV and respiratory protection are the top two controls in my mind for controlling hexavalent chromium exposure. We shouldn't just rely on PPE, because what the LEV does as well is it helps protect people around that person. So you might have that situation that I talked about earlier of the welder in the workshop, and you've got a fabricator beside them, and the welder can be then welding with their PPE and their LEV there, and then the fabricator who doesn't have any PPE on, we can still look to make sure that they are being protected as well, and using LEV will certainly help with that. Otherwise, if the fume builds up and we just got stainless steel welding going on, it might be a situation where everyone in the workshop needs PPE instead of just the person doing the welding.
The other thing to consider with LEV is you can put the best LEV system in the world in your workplace, but if the workers aren't convinced that they should be using it, or they haven't been shown how to use it effectively, then it can be quite a waste of time. We've seen loads of cases where, you know, we've gone into work sites where they've got a great LEV system, but the workers just aren't using it properly on a day-to-day basis because the PCBU hasn't taken the time to show them how important the use of it is, or so they don't understand that it's providing that extra level of protection. They often put on a respirator and say, yeah, now that's my protection. I don't need to use that, or that takes too much time to move around, or it's not working properly is quite a good range of excuses that you get from workers. So that training is a critical step in making sure that the controls that are in place are effective and protecting the workers.
So the next question here is, we're talking a lot about stainless steel and the low WES. Is there any issue in using LEV or other ventilation for just moving the gas to the atmosphere? I presume you mean the welding fume to the atmosphere. Any local population effects? I'm not 100% sure what you mean by local population effects.
I think they mean like in the local neighborhood, if you're just venting to the...
Oh, right, yeah. Venting outside.
Yeah.
So if we stop talking about stainless steel welding and just talk about something like mild steel welding, then what we can do is we can use other controls to reduce exposure, to show so that people don't need to wear respiratory protection. We need to demonstrate that those controls are effective using exposure monitoring. So we can use the local exhaust ventilation, like I talked about earlier, the snorkel movable system, which can be on a movable unit, like a Nederman LEV unit, or the snorkels can also be on an in situ system with snorkels coming down from the main ducting. Other ventilation, general ventilation, can also help with controlling exposure. Not so much the exposure of the welder, but certainly the exposure of people working in the workshop. And there are other controls that we can look at to reduce welding fumes. So if we just talk about mild steel, welding of mild steel doesn't always mean you have to wear respiratory protection like it does for stainless steel welding, but you need to have that risk measured using exposure monitoring to confirm that you don't need that respiratory protection. And lots of workshops only do a little bit of welding here and there, whereas others do welding almost continually, day in, day out. So there's a big range in expected concentrations there.
Yeah, I'm getting back to the local population effects, say outside the building, etc. Most LEV systems will have a filtration system in place, if anything, to protect the fans and the moving parts. So most of the hazardous material will get captured in those vents, and then dilution is pretty massive once you get into the outside air. So not expecting local health effects.
Are welding curtains to enclose the welding area effective along with ventilation and PPE, especially for other workers using the workshop that are near welders? So the welding curtains are primarily there to shield people from the UV radiation and the welder's flash and that kind of thing. If there is extraction directly above the curtained area, that could help with directing welding fume up and then out of the building. But even in areas where there are curtained off welding booths, we still see the haze build up if there's a lot of welding going on, because it just doesn't get extracted quickly enough in those types of situations. So it's more situation dependent for the curtains. And we've got in New Zealand, if the filtration unit in the LEV, is the filtration unit in the LEV system required? So there's nothing legislative that I'm aware of that requires there to be a filtration unit in the LEV system, because remember, but I would suggest that that's a good idea to have a particulate filter on there to filter out that welding fume. But even if the LEV is used, draws air away from the welder, that's controlling the fume for that welder. But if it's reintroduced back into the workshop, it could still build up in the workshop. So having a particulate filter on your LEV system would certainly be preferable.
Yeah, I mean, the other thing, if you do have any air compressors that supply respirable or breathable air to other workers, say in paint booths, it's really important where those are positioned as well. You don't want to put the compressor with air intakes next to where people are welding. I've seen that a couple of times, because they'll just draw I mean, it's a filtered system, so probably not the worst thing, but you certainly want to be putting fresh air through that system as much as possible. Outside draw would be much more preferable.
We've got no other questions there, so if you do have some questions, please type them out. And in the meantime, I'll just give you all a bit of an overview on how we do the exposure monitoring. And we're typically looking for 3 or 4 different types of contaminants. So we're looking for welding fume, which is inhalable dust, and so that involves a filter sitting up on the lapel that air is sucked into. We're also looking for different types of metals in that welding fume. So, and that depends on the type of metal and type of welding technique being used. So that's always situation dependent. But there are usually key ones that come up most of the time. Then we're also looking for respirable metals. So I mentioned respirable dust being the really fine stuff that gets into your lungs. So the New Zealand Workplace Exposure Standards has a lot of metals that are respirable metals. So you can't monitor them you can't measure for them in your inhalable dust. You've got to do a respirable dust method to compare against those. And then also hexavalent chromium. So we still can do and sometimes do exposure monitoring for hexavalent chromium. And what that can tell us is what level of respiratory protection is needed. So if we suspect there are super duper high levels and we want to make sure that the type of respiratory protection we're recommending is correct for that situation, then we can do exposure monitoring for hexavalent chromium. And a really important thing to consider during exposure monitoring is your field blanks. You've got to have field blanks for all of these items. It's just a really important quality part of the exposure monitoring. Jared Chisnell from @Source has just put up a question there, and @Source is where you can get Nederman LEV units. So he's just put that for filtering AS/NZS 1668.2 objection or discharge, usually common sense applies. So welding fume could be considered as a objectionable discharge. There may be some regulatory requirement there, but I'm not 100% familiar with that, so please do your research before you take my word for it. Also, we've got which are the safest welding types? Is it worth changing welding processes to avoid a dirtier welding type? So sometimes the welding type is dependent on the metal being used. So you can't always just change welding type because your welding won't work for particular metals. Probably the metal that is the safest is aluminium, because there's just aluminium in it, and aluminium isn't particularly hazardous. It can be quite fumey, can be high levels of welding fume, but from a toxicity point of view, from a disease point of view, probably aluminium be the cleanest metal, if there's such a thing. But it can look the dirtiest because it produces a lot of fume, so it's a bit of a tricky one.
Yeah, I don't know lots about it, but I have heard that there are different, like we can take welding right out of it and use a cold joining technique on some applications, but I doubt that it is super applicable in all applications.
And it's worth asking those kinds of questions of your engineering team, or or explore those kinds of options. So might not always be practical, but it's worth asking the question because it will be situation dependent as well.
I mean, the common welding types that we do see are stick welding, or and MIG. are the most common that we see, Bridget. What do you think?
Yeah, definitely. MIG with mild steel, and then TIG with stainless or aluminium mostly. Okay, that's come to the end of the questions, so I'm happy to end the panel discussion there. If you do have any questions, please pop them on, and Paul and I will stick around for 5 or so minutes after. So yeah, you can still put questions up, but otherwise, thanks everyone for attending. We hope you got something out of it. If you have any specific questions you'd like to ask myself or Paul, please head to our website, chemsafety.co.nz, and our emails are on the About Us page.
Yeah, thanks everyone for your great questions. That was really fun. Thanks.